Huh? Never mind. That's not the right answer.
There's really no right or wrong answer.
Isn't it just the cross?
Multiply cross, very good. Right? So we learned actually in chapter, I think chapter 1, we said, okay, well, if you're multiplying two fractions, we just multiply the numerator cross, multiply the denominator cross, right? So 3 times 2 is 6, 5 times 7 is 35. Can you reduce it?
No.
No. And that would be the answer, right? So we kind of using the same approach as we start dealing with multiplying rational expression. So let's take an example and see if we can simplify this. So I have 9x, 16. Let's try to solve 16 and see if we can. This is on page 394. Page 394. And the example they're giving us, or the problem they're giving us, 9x over 10 times 5 over x squared. Multiply across, 5 times 9 is 45. X, right? Divided by 10 times x squared is 10x squared. Can I, 45 and 10 can be simplified or reduced? By 5, so 5 goes into how many times? 9, and 5 is going to go 10 how many times? 2. X and x squared.
X.
Where is going to be left to x?
At the bottom.
At the top or at the bottom? Bottom, very good. So, what are you going to have? What's going to look like the answer?
9 over 2x.
9 over 2x, very good. Right, so we multiply and we reduce it, right? So kind of the same thing just like we were doing in the fraction, right? Now, since this one is a little bit easier because we have only one term, right? As we start diving into this chapter, what's going to happen, we're going to be dealing with multiple terms, so it might be 9x squared plus 5x divided by something. Now you can just multiply, because once you multiply, it becomes more complicated problem, right? So before we start multiplying, what we're going to do, we're going to try to find the factors, and then you're going to see what are the common factors we can cancel before we can do the multiplication, right? So we're not dealing with the large polynomials. Okay, any problem with this example though, the one we just did? Nope. All right, so let's pick a problem where we have to deal with some factoring. All right, so let's take a look at, for example, problem number 24. Okay, so 24. So we have 3 over a squared plus a times 2a plus 2
There we go.
over. Don't pay attention to him. Okay. So again, what is the operation between these two rational expressions? Multiplication, right? Now, as we keep tackling this problem, now we just don't have only just one term. Now we got two terms, right? And here too also we got two terms. So before we can do multiply, we want to find the factors, and then we can cross the factors out that are common before we can do the multiply, right? Okay, so let's focus on very first rational expression right here. Ignore this for a moment. 3 is already factored, so there's nothing you can do here for factoring, right? At the bottom you've got two terms, right? Is there anything common between these two which you can factor it out? A, right? Okay. So if I factor out A, what are you going to have left at the bottom? So factor out A, what are you going to have left? 1?
A plus 1.
A plus 1, very good. So out of the A squared is going to be A, and then whenever you factor out completely, you always have to leave 1, right? Any questions for this one? What did we do? Yes, no? Right. Times. Now there's nothing else you can do factor here in the first rational expression, right? So what we have done, wherever we can do the factoring, we just did the factoring and then wrote down the factors, right, for the polynomial. Now we move on to the second one. So again, here we've got rational expression, multiple terms at the top, right? So can we factor out anything common in the numerator on the second one? 2. Very good. So if I factor out 2, what are you going to have inside the parentheses? A plus 1. Very good. Over 6. Now 6, since it's a number, we don't have to write the factor, right? Okay. Any questions so far? Okay. Now since it's a multiplication, now we can see what are the denominators and numerators we can cross. So what are the factors we can simplify?
3 and 6.
See this a plus 1, and then also you have a plus 1, right? So we can cancel those out. Everybody's okay with it? Right, okay. Now look at this right here. 3 times 2 is what? 6, and at the bottom also we have 6, right? So we can do 2 steps, for example, 2 times 1 and 2 times 3 is going to be 6, and this 3 and 3 will cancel each other out as well, right? So there's nothing else left at the top because 3 is gone, 2 is gone, a plus is 1. So since everything is gone at the top, what are you going to have left to it?
No, time out.
2 steps back, could you go 2 steps back?
Yeah.
Erase.
Okay, okay. So let's. I think we were okay up to here.
Yeah.
Hold on.
You gotta take a breath.
You tried the Kansas City shuffle on us.
My brain didn't
Okay, so this was very obvious. A plus 1, right?
cross that.
Okay, so that's it done.
And then 3 times 2.
And you start talking about 3 and 6 and
Okay. What about this 2 and 6? Can we simplify this?
yes,
2 times 1. 2 is going to go 6 how many times?
3.
Do we have to simplify that first?
No, you don't have to, but I mean, since
Okay.
we're cross canceling, we can do that, right? So otherwise, we can reduce it later on.
Yeah,
Not a
that's
big
what I
deal.
wanted.
No, I'm just saying, what if I just, because I would have just crossed out the 3 and then, it still would have been the same thing.
Right. Okay. Any questions so far here? Okay. Now we have a 3 at the top, and we also have a 3 remaining at the bottom, right? So we can also cancel them. That's what I was doing before. So. Okay. So now the question is, what do we have left at the top? Everything got canceled. So everything got canceled. It means you're always going to have 1 left, right? So I'm going to write down 1 over. At the bottom, what do we have? We have a. This a plus 1 is already gone. 3 is gone. 6 is gone, right? So what are you going to have left? A. So 1 over a. That would be the answer for this case, right?
Do you pick the problems on Alex, or is they picked at random, or is it the same? Everybody gets the same problems? How does that work?
Alex, when you
Yeah.
do the exercises?
Yeah, do you pick those?
No, I don't take those.
Oh.
Those are all come from the, the University of Phoenix curriculum.